This used to be a Phillips head screw. Now it is no head screw. Yeah, I swear to God, it looks like someone used a drill. Hello friends, welcome back to the bench. Today we're gonna take a look at the Lenovo Chromebook, which doesn't charge, doesn't turn on. However, it does negotiate voltage. However, we're gonna replace the USB-C chip just to be sure and check for shorts. Maybe, hopefully it doesn't have any shorts because I still don't have my thermal camera yet until next week, but finally I decided to invest in one. It saves so much time. Alright, let's take a look. Maybe we can fix this one. Alrighty, here it is. It got quite a big beating. The board is probably bent a little, so there might be some broken traces. It kind of looks, I don't know, like almost like a car went over it. Because who would, if you sat on it, or maybe it just dropped. It probably dropped. Alright, let's see what it can do. So let's get the meter. This is USB-C powered. Maybe let's do it this way. Okay, it's at least starting. And we have 15 volts. And it dies. And resets. And dies quickly this time. 0.06. And now the current didn't even go higher. Before it went almost to 1 amp, 0.9, something like that. Now it's dying at yeah, there was 0.8. Yeah, so as soon as it starts getting more current, it dies. So this could be as easy as disconnecting the battery and see what the difference is. Oh, the screws are missing. All the screws. Oh my god. I feel like every laptop that I get is missing at least one screw, and I always have to replace it, and I'm running out of screws rapidly. Alrighty, I love these laptops because you just open the back and you have access pretty much to everything. And it looks like the battery is already disconnected. So someone had a similar idea, which didn't help. Okay, so no point in checking the battery because I could connect the power to the battery and see if it's charging, but if it's disconnected and it's behaving the same way, now can it charge from the other USB-C port? Let's see. Okay, we have a little fan span. 0.8, 0.7, and it rebooted again and again. It's kind of lighting up over here, so LED is lighting up. We have a fan span, but it's not starting, which means actually not sure what it means. Let's see if the anything heating up here. So we have over here let's grab a scope And let's see, because our chart chip, our USB-C chip, is okay. So TPS65990. So that's our chip that is responsible for communicating with the charger and telling it how much, what's the voltage that it needs, and all that fun stuff. And so if it was broken, if the chip was at fault here, we would likely either not see anything from the meter, it would just remain black, or it would just not consume any current and it would stay at 5 volts. So I don't expect this chip to be broken. Second thing, those two MOSFETs over here, I also don't expect those to be faulty, and the reason is that the computer turns on. So these are basically the switches that let current in. And let's see, the gate and the source, gate drain, no shorts, and this one, gate source, gate drain. Yeah, it's all good. And they are probably just bridged over here. Yeah, I don't have a beeper on, but yeah, but no shorts, no nothing. I didn't expect it. Since we're here, let's test a few caps around here. I don't see any signs of corrosion. Okay, so let's see what it does when I do connect the battery. Oh, now it's grabbing a lot more. 1.7, 2.5 amps. Yeah, the fan spin. So as soon as the battery is unrelated, it's charging the battery. It tries to boot, and that's when it dies. So the battery is probably all good. So could it be from the chip? Could it be that the USB-C replacement would help with this? I don't think so, because it does. Yeah, I don't think so. So let's do this. Let's just start disconnecting stuff. I expect a short somewhere. Keyboard, not really necessary, but I've seen cases where the short was on the keyboard. That was years ago. It was not on the laptop. It was in the stationary computer. But the short was on the keyboard. And once you disconnected the keyboard, computer worked just fine. So it was just messing up the boot process. Easy. Okay, so now we have disconnected everything, and let's see what's gonna happen. And it rebooted now, so no effect. Okay, no effect means none of these were responsible. Let's disconnect this one. This is the Is this another? Oh, this is the on button and all that. It probably won't work without that, but let's see. Oh, now it went to 1.1 amp for a second and reboot, so no effect. Now let's delete this guy. It's kind of like, so when the fans start spinning this quickly, that means the CPU turned on, and as it does, it reboots. So it could be short on the CPU, and CPU is warming up. At this little power that I'm giving it, and we're talking about 50 milliwatts, and it's heating up this much, this is likely the reason. Okay, since it's going up to 15 volts, I really don't think the charging chip is at fault here. Okay, same behavior. Is there anything else we can disconnect? Well, touchpad, I guess. I would not expect a touchpad to be responsible for such behavior, but let's do it. I don't feel anything hot over here. Now we can actually disconnect the Wi-Fi card. That also shouldn't be the issue, but we don't know until we check. Now it rebooted very quickly. Now it went to 1 amp. But pretty much the same stuff. Okay, not much more that we can disconnect. So the problem is on the board. So the board must come out. Oh, looks like it already someone tried disassembling. So someone got very far into the process. Oh my god, this one's completely... Jesus. Oh my god. It's like a nail file. This must have been through quite a few hands already. With every person taking a look at it, okay, it's working very quickly. Especially someone equipped with tools that do this. Hit a screw. But that's not even the worst one. This used to be a Phillips head screw. Now it is no head screw. Yeah, I swear to God, it looks like someone used a drill to try to unscrew this. This is absolutely ridiculous. Okay. This must over here. here? Is this last nope. No, it's probably it's not. Nice. Maybe this. I'm not sure. Okay, let's see these coils here. 0.5 ohms. 0.6. So the coils are checking for resistance. We're checking if they're lucky. Because they all short, because there's no. I'm gonna go. Let's check these guys. Got one looking for the points. And I'm lucky. And good. No, oh, it's charging. It's just charging. Let's see what this is. Is this faster? Or something else? Let's see if this is 5.5 ohms. So that's not being faster. It's probably. Let's see what line now. Oh, it's 0.5. 0.5. Oh, that's fine. The other one is here. It's not right. Looks like yeah. It is over here. It's not shorted. And right next to it, this guy, let's look where it goes. I think I like this one. Looks like this guy. Nope. So now it goes. It disappears this here. Now it's going to go. So that's not it comes. So yeah, this all these. So this is how I release the points. You have more data, that's fine. You do. And so where is this so shorted? That's not sure this is. What's 24? It's not like that. This guy. From this guy. Yeah, this guy. And this here somewhere there. Yeah. Oh, over. And that's the capacitor. Is it though? Yeah. Where's this going? Not the capacitor. Alright, so we just need to take the board out, connected. Not sure how to do it without, but it is bent here, so the whole board is bent. So let's get some screws off and relieve this tension on it. Let's see something different. What's this? Okay, so what's the bent? Yes, the bent. I have to change out. Okay, let's relieve the tension. Yeah. So that's off. Okay. It's completely bent. Look at this. I'm not sure we'll be able to get it fixed, because there's no way to know what kind of damage did this deformation caused. It could be broken traces, and this is multi-layer board. It could be components that got desoldered, cold solders, cracked solder, all kinds of stuff. Let's see what it does. When connected like this. It's doing the same thing, I think, yeah, and it's resetting as it tries to turn on, I assume, or start charging the battery or something. I think we can safely eliminate the charging chip, and I didn't catch any shorts over here, which doesn't mean they don't exist. I just didn't catch any. It feels like, especially since the CPU gets warm, I would expect the CPU to be shorted. I would expect, that initial startup procedure is to deliver power. So it turns on, it delivers power to everything it needs, then the CPU takes over, and then it dies. Because these chips will not allow too much current going through. And the power management chip, which I would expect that if there's anything wrong with the power management chip, it would just not turn on. We would get nothing from the meter, and it would stay at 5 volts. But since it's going to 15 volts, CPU doesn't need 15 volts, but that's just the other big problem is that it turns off very quickly. It's gonna be hard to measure voltages, but that will be next step. So I want to see if we're getting nice 3.3 or whatever the voltage the CPU needs, maybe 2.8, 1.8, whatever. Then this is probably the drive or memory or both underneath there or underneath there. So I can identify few converters here. So let's check the voltages on all converters and go from there. Okay, after several measurements on restarting device, I was getting a little bit of heat from over here, so I treated it with alcohol to see which one evaporates fastest. This little one over here seemed to be exerting a little more heat than the rest of them, but that doesn't mean it's anything unusual. However, during the process, this happened. Now when I turn it on, you can see, but now we have 5 volts and no current flowing. So this is exactly how it behaves when there's a problem with this TPS chip. But the chip was working a minute ago, and it was kind of working, not working, but in a stable fashion. I started playing with it, and now it doesn't work. So this is what I suspect at the moment. Since our band is over here, this is what we use for charging. And by the way, it's not charging from the other port either. It behaves the same. But whichever port you're charging it with, it should be managed by this chip. So since it is bent here, I suspect that there's just either broken trace or the chip is no longer making good connection with the traces because of that bend. So I'm gonna try to reflow it. I'm not sure that would help, but I don't really have any other ideas other than replacing the chip. But this one is TPS, what was it? It wasn't, it's this one. Take a look. Oh, you won't take a look because I would have to connect the camera. There you go, and just give it a second. TPS65990. It's very similar to all the other ones. There's two MOSFETs on the output. I don't see the coil, but okay, why is the camera not working still? It should be working by now. Oh, that's why. Sorry. Okay. So this is TPS65990. Right, and those two MOSFETs on the output, and I assume the coil it's using is this one, because that's the closest one. But there's another MOSFET over here. I'm not sure. There should be a coil on the output of this one. So yeah, let's reflow it and see what happens. Alrighty, I don't really have high hopes for it, because I do believe it's the board that is actually damaged through the physical damage to the board, and that's what's causing the issue. But short 2 weeks later, I received the chips, 2 of them, just in case, and let's just resolder it. I really don't think that is the issue. I do believe that this chip is okay. But on the off chance that maybe it was damaged and I just pushed it over the last mile of being damaged, and maybe the replacement will work. But for now, it's not negotiating voltage anymore as it did before. So let's replace the chip and see what's gonna happen. Alrighty, so the chip replacement did not help, didn't make any difference, which was kind of to be expected, but I wanted to eliminate physical damage to the board. It's stuck on 5 volts, right, and not pulling any power, regardless of whether the battery is connected or not. So it's not booting anymore, right? Now, since it was booting before but turning off, I figured, I know, the damaged board, or maybe that chip, I just pushed it over the edge. But no, the chip was fine. So I started searching for shorts. What I did find is not exactly dead shorts, but there is 10 ohms on these capacitors here, like pretty much all of them. 40 ohms on these and 10 ohms on these. When I was diagnosing it, or just keeping it running and just dousing with various components with alcohol, seeing which ones are evaporating, these ones over here were pretty warm, and also they have like 40 ohms, 42 ohms on every one of them. Is that good? Probably not, but it's not a dead short. Here, on the other hand, it's only 10 ohms. So that would kind of make sense that there's a slight short, because shorts are not always dead shorts. Some time ago, you can find it on my channel, the power amplifier, or was it, no, I think it was a power supply, but basically the transistor turned into like 20 ohm resistor or 10 ohm resistor. But that was bipolar transistor, and bipolar transistors can do that. It's a little less common with MOSFETs, but I also checked all the MOSFETs and none of them are shorted. So what I did, I just basically put 1 volt on a power supply, right, and injected over here. Actually, let me switch to the scope. Let's see, these guys, which one was it? Probably this one. So if I inject voltage on this guy, yeah, it's pulling 254 milliamps at 1 volt, so quarter watt, right? And I kept it for a while because 1 volt shouldn't break anything, and see what's getting warm. And unfortunately, the only thing that is getting warm is the CPU or GPU. This is probably both of them here, but this is the only thing that is getting warm when I inject voltage. So there's not much I can do with this thing. However, I will do this. So once my thermal camera is delivered, which should be next week, I will confirm this with a thermal camera. Let's see, 1, 2, 2, 3, and 4. So let's just put it back as it is. And I also checked all the caps on the other side. Everything's good there. It's only in this area around the CPU. So most likely that's our culprit. But we'll confirm it. This time I don't want to deem it no fix until I actually confirm. That's why I invested in a thermal camera. That will save me so much time working on shorted boards like these. Alright, it's not called no fix yet. It's not deemed not fix yet, or no fix. just yet, so stay tuned until I receive my thermal camera, and maybe we can actually fix this board. If not, we have some working components that we can pull off of it, so that's a good thing. And the USB-C chip is okay as well, so now I have 2 working, or actually 3 working chips like that. Anyways, thank you guys very much for watching, and I'll see you in the next one.